Hello, welcome back to Getting Your Ducks in a Row. Today I'm joined by Andy Kitson, co-founder of Trace SI, to talk about a niche area of construction, non-intrusive structural investigations. In this episode, we get into why drilling less doesn't mean knowing less, how tools like iCAM are helping us understand structural integrity without breaking anything open, and why smarter scanning can extend asset life, reduce risk, and deliver better results for everyone involved. We also talk about the role of AI in the industry, the future of infrastructure inspection, and what it really takes to build a niche business that challenges the status quo. If you work with structures or just want to know what's really going on beneath the surface, this one's for you. Enjoy. Andy, good afternoon. Welcome to the show.
Afternoon. Thank you for having us.
You're welcome. So if we just start off for our listeners, could you give us a bit of a rundown for what sort of drew you into the industry of non-intrusive structural investigations? I know you were on the fairly traditional side of surveying first, sort of out of uni, I imagine?
No. So I failed all my A-levels, and then I applied for a job in a newspaper as a assistant utility surveyor. So long time ago, no idea what I was doing, never heard of radar. I knew nothing about the construction industry. It was just kind of like, I need a job, and they didn't ask too many questions. So I applied for that. I did that, trained as a utility surveyor for a couple of years. And then this was 2008. So recession hit, lots of things went sideways, and I ended up working for an engineering consultancy company that used my utility surveying GPR background and then started merging it in with the concrete and non-destructive kind of testing. And then, so I spent many years with them learning how things are built, where construction is, what's going on in concrete, and everything that we know about it, and then bringing in that non-intrusive side of things and analyzing that. So I worked there for 8 years, something like that. Moved to another company, semi back to the sort of utility surveying kind of thing, but with my eye towards the concrete non-destructive things. And then 3 years ago, we set up Trace Structural Investigations to, like, the goal generally is to improve how non-destructive and concrete structural investigations are undertaken to try and better sort of the industry. Like, we're learning, we're trying to help others learn and provide support. So it was kind of there was no real plan to it until like 5 years ago, when you realize, you know what, this is actually what I want to do. This is where I like to be. Because yeah, I knew none of this when I started. I had no goal. It was literally, someone needs the money so that I can live. But I found I was good at it, found I enjoyed it, and then we sort of migrated to where we are. And so my co-director, Kyle, he did do the uni, he finished uni, worked for us in the structural consultancy company, and then came in, and we've worked together in 3 companies, and then left together to sort of, with that goal in mind. His is slightly more traditional route, mine's a little bit more chaotic, but it kind of shows that you can get pretty well if you put your mind to something. You know what you're doing. You don't need to go through that. I've got Kyle to the technical side of those things, so it helps.
Yeah, I suppose. Yeah, I was going to say having that technical side helps, but it's an interesting journey and sounds a bit of a sort of fly by the seat of your pants, and you found your place, as it were, in perhaps not the most conventional way for an engineer. Why leap from being employed, I presume? And you were at Sandberg, right? Which is an established consultancy, right? It's an established business.
Yeah, so I left Sandberg 2017, 18, something like that. It was basically looking for a new challenge, doing something else, moving more into the sales and business development side of things. Whereas before I was like, personnel manager, project manager. I didn't have a lot of experience on the sales side of things. And so I went to work for Murphy Geospatial, which is a very massive geospatial surveying company, doing sales with them. And to be honest, the knowledge that I gained there is probably as important in terms of starting my own company and bringing new work in, because that sales side of things is what you need. It doesn't matter how good you are at what you do if no one knows you do it, or you can't talk about it to the clients and get your point across. So it was to get that kind of new challenge, something different, but still within the same industry.
Yeah, and that having that sales background going into starting your own business, which is, it's a bit of a leap for anyone. Especially I think, I don't know, I was going to say more so when you're employed and then you go into starting your own business, but it's a leap regardless. But having that sales background, I imagine, just helps you massively as you've gone into working for yourself, because you have more of an understanding on how to get new business, right? Because it's all well and good being good at what you do, as in the service you provide, but being able to market and sell it and understanding the dynamics of how people work is a very different thing.
Yeah, 100%. I think if anyone was realize that they're at the stage they know what they're doing, even if you just went in as like a junior salesperson or something like that, just to get a better understanding of that role, it's massive. Because it's so very different to, like, we used to do quotes, proposals, and we used to talk to clients and things like that, but it was very much a reactive kind of, we're part of a big organization. People come to us, lots of repeat customers. Everyone knows good names, and responding to that is really easy. Like, the work comes to you, you just have to win it. Going out and hunting for work, it's a very different beast. And I would say when I talk to other people in the industry who've set up and things like that, it's definitely the bit that where they get more successful or less successful based on that sort of sales thing.
Yeah, and how well you can relate to people and build relationships, I suppose. In terms of Trace, I'm interested why that. I mean, Trace sort of occupies, I would say, fairly small niche within quite a large industry. Why non-intrusive structural investigations, and why the focus on concrete? Why that route?
A lot of it, I would say, is where we ended up. Most of our experiences in concrete, a lot in like masonry, brick, and stone as well. There's sort of two sides to sort of the non-intrusive, non-destructive kind of side. There's a lot on the steel, weld testing, engineering, kind of that side of things. And normally when people say NDT, that's kind of where their mind goes. We focus on the concrete partly because it's what we're good at, but also because there's not that many people that focus on non-intrusive analysis of concrete structures. So there's a reasonable market and there's a reasonable large commercial entities for structural investigations of concrete, masonry, and things like that. They typically focus very heavily on intrusive works. They do targeted NDT, but it's not to the same extent that we do. So we take a lot of that NDT and then apply the analysis section to it. And what we found as we've sort of progressed and we've grown over, not just in Chase, but in previous companies, the elements that we offer are not always covered by other clients. So we work with a lot of other structural investigation companies to bring in that niche works. And one, we're very passionate about trying to do more non-intrusive, because the more non-intrusive we do, the cheaper the project, the better the result, and you can do targeted stuff. We still get the traditional, but we're doing it faster and quicker. But the other thing is, being niche has meant that we're very well known for what we do. We offer great value for what we do, and we can apply that to a much larger sort of area, and we can get more work in on the niche rather than trying to like spread ourselves really thin
Being
and
everything
compete
to
against
everyone. Yeah.
Yeah. And we end up competing against people that are much larger and have a much better, like, they have a more established name. So if we go in and do niche, our name is for the niche. And okay, maybe we miss out on huge projects, but the projects we do, we'll get there. But the projects for the moment that we do is much more targeted, and business wise, it works very well.
There's a piece there around the sort of innovation, and you mentioned there the sort of intrusive methods perhaps being the more traditional, and what you're doing is, it's coming away from that, making it sometimes, I imagine, safer, more efficient, more cost effective for the client, less time so the projects can be delivered, more swiftly. So there's a lot of benefits there. And coming away from those traditional methods and offering something to the industry that is different and is innovative makes you stand out of itself. By just doing that, you're different. And I think what you said there about focusing on one thing rather than being everything to everyone and just becoming really good at that thing is something that I think a lot of businesses sometimes miss out on, and they're trying to do a bit of everything and saying they become a jack of all trades and a master of none. What are you seeing in terms of uptake from the industry, like this non-intrusive method? Is it now in general outweighing the more traditional way, or is there still a big sort of liking towards the more traditional methods?
It's definitely growing. There's definitely more people scoping it. Engineers are starting to understand its value better. I would say it's not going far enough. There is very much a hang up on let's do some really small targeted non-intrusive stuff and then like bulk the intrusive works, or we're going to do in non-intrusive stuff but in like a less than efficient way. So our approach is, it's not exactly this, but essentially scan everything with various GPR or ultrasonics or whatever systems we need for the project, but collect as much information as possible. It can be done super quick, super efficiently, and then use that to target the intrusive works. And you get a much better result. Clients that follow our approach and that we consult with tend to be really happy with it. Whereas the traditional method is let's do everything at once, and then we'll do little bits of NDT. Traditionally, that's a 600 mil square or meter square area. We'll do a little bit there, we'll do a little bit over there. And because they only do these little targeted bits, and not everyone in the industry does the analysis of the intrusive work, the non-intrusive work, they don't do the analysis. The client doesn't really get much value out of it. And so they're not going to scope it as much, again, next time, like they're not scoping it as well as they could do. So the uptake is getting there. There is more understanding of what it can do, but what we're trying to do is improve that understanding, improve that uptake. And a lot of our sales and BD, going back to that, is kind of the education and consultative side of things with the clients. Say, look, scope is great. It will give you the answers, but let's go with, look at this scope. We'll do a lot more non-intrusive. We'll get the job done half the time. More information at the end of it, and cheaper, or on par at the same time, so we can kind of balance it. It's getting there. It is getting there. Like we were on a project last night that looking at post-tension inspection. Traditionally, that is fully intrusive. Everyone does intrusive. Non-intrusive methods have been around for a while. They've been spearheaded by not just us but others as well, and that's starting to get more and more into scopes for bridges and post-tension structures, which again, it means that we can target our intrusive works, we can limit the number of holes, we can limit the amount of road closures and time on site, because we did non-intrusive assessment of like nearly 60 tendons and 2 nights over 2 bridges, whereas the intrusive works for that project is looking at 3 weeks.
Wow. And you've done that
So
in 2 nights?
Yeah, so it still needs intrusive works, don't get me wrong, it still needs follow-ups and things like that, but you could reduce that intrusive works down for maybe
it's still not going to be 3 weeks.
Yeah so there's kind of an example, and it just needs more and more. But what we find is once engineers have sort of understood, we've gone through that process with them and sort of shown them the differences, they tend to be on board, which again for us is good, because like I say, from the beginning, we want to improve the industry, we want to bring more non-intrusive work out there, and the more engineers understand what can be done, the more they scope it, and then the industry can grow from that. Like we're confident that there's enough work out there that even if we don't win it all, others will pick it up, and then the industry will grow and improve. Obviously we're the best and we want to win it all, but like we understand that it's out there, and the more people that do what we do, the better the industry at the end of the day. So that's kind of our goal, and like you said, that's what we're pushing for.
And you mentioned there a sort of preference still overall, shall we say, for the more traditional methods. Why is that? Do you think it's just what's familiar, what's comfortable, it's the known, and there's just like with pretty much anything, there's always a bit of resistance at the beginning when there's a new way of doing things, and people just want it to live in the industry for a bit longer and be tested by others before they sort of make the leap. Is that what you're seeing, or is there something else there?
Partly, there is definitely that. I could point to 1,000 different papers backing everything up that we've done, tests and simulations and all that stuff. It's well documented. That documentation is anything but an engineer that's been doing it in one way or had results that have ticked all the boxes and the process has worked. It still works. So it's hard to sway them because they've not experienced it. The other side of things is the traditional method is typically what's offered. So a lot of other people in the industry, they'll go, okay, so you want 100 fail scans over this building, 13 cores, 200 breakouts, whatever it is. That's what the scope says. We're just going to do that. We're going to offer that. So's company B, company C, price goes in. They pick out one of them. So there's a status quo that is understood with engineers scoping, structural investigation companies just meeting that scope and going off. We prefer to try and work towards the engineers saying what they need to know, rather than saying we need 50 fail scans, 100 breakouts, or whatever it is. Realistically, the client actually needs to know, how is this being built? How is that column connected to the floor slab? What the foundations are? Where's their corrosion risk and things like that? And the more that engineers realize that the structural investigation companies, they're the experts, they know what they're doing, and you can just ask those questions. So instead of a 200-page scope saying you need this, this, and this, you could just have a one-page scope, essentially just saying, I need to know A, B, and C. Structural engineers, the investigation companies can go out in there and work out how they would do that to answer the questions of the client. QS issues, there is QS issues on that because they you want the same, and look at the price. It's the easiest way. But realistically, it doesn't really matter. The methodology of getting that information can vary between clients. Sorry, different companies doing things. But as long as we answer those questions, that's what we need to do at the end of the day.
And that sort of leads in, Andy, to the next thing that I wanted to discuss with you is it's the end result. So what you're delivering your clients with. And you mentioned there, rather than just saying, almost like going back to the sales side, if we can for a second, rather than just saying these are the services we provide, it's more, by the sounds of what you're saying, it's more lean towards what do you need to find out? What do you need to know? And here is the answer, not here is a report that you then need to decipher, have a PhD in, I don't know, bar charts or whatever it is you give these guys. But it's more, right, okay, this is the raw data, and now from that raw data, this is the answer you need to answer your question. Is that what I'm getting? Is that right?
That's, yeah, very much the approach that we do. Engineers typically get a lot of images, first scan images, or this is a bar, it's roughly in this location, that kind of thing. There's it very much, we want these tests done, these are the results of those tests. Whereas we focus on the fact that, why do you want those tests done? You want to know its construction to calculate strength and things like that. Okay, we'll give you that information. We don't send them the 5,000 radargrams and images and things that we've collected. We've gone through all that. We've analyzed that as the experts in the radar, as the experts in structural investigations, as the people who know how to tie all that information together. We distill that down into something usable that the client can then go, okay, so the slab's got 2 layers of reinforcement in it. It's got hogging reinforcement here. It's got beams and connection details. And then they can do the calculations. They can do everything. And we're trying to sell that methodology, that time, because one, we want to save them time of scoping. We want to save them time once they've got the data of having to analyze it and try and work out what any of it means. So it's sort of twofold, both before and after, that's kind of our pitch when we're talking to new clients. And it does resonate fairly well because, as I'm sure every person at work they don't have enough time to do
Yeah.
everything. So if we can take it off the plate as this is what we do, again, we are niche, we are experts in what we do, we can take that off their plate and they can go out and tender it.
And is there an element of sharing risk in that? So if I'm a client and I come to you and I say I need to know the integrity of this structure, because let's just use, I know you guys don't really do too much residential, but it's just easier for my brain. If I'm, say, a developer and I've got I need to retrofit and I've got an old hospital, for example, that was 2 stories and I want to turn it into a block of flats, and I could say to you guys, right, can you come and look at these foundations, let me know what the integrity is and whether I can add on another 2 stories as an example. By getting you to do that, presumably there's also an element of sharing the risk if anything goes wrong, right? And that potentially is a benefit to people. I don't know.
There is. So we don't say, like, as pretty much all sorts of investigation companies, we will never say this is what you can do. We just say this is what's there, this is the evidence, the reason, and our confidence level in variable structure. But by doing that analysis, by distilling it, we do take on that risk. We do, rather than just collecting data and giving that raw data to the client, we do take on risk in the analysis. And like we're fine with that because we know what we're doing is right. We can back it up. It's not a problem. And there is, with even with intrusive stuff, but especially with NUT, there is always a little bits of grey areas. You try and filter them out through various methods and backing it up with different systems. But there is always grey areas. But those grey areas will always be there even if the engineer's doing the analysis. But we're just better placed to understand it. And so we do take on more risk than just a coring company or just going to go do 20 samples, because we've provided some interpretive, we provided interpretation of that those results.
And is there an element of, in comparison to more traditional methods, which are intrusive, are your methods more sustainable? Now, that might sound like a strange question, but sustainability in the construction industry is like huge. And, I've been banging the drum on it for far too long, and any of our regular listeners are probably sick of hearing about it. But is there an argument to say that the way you work, obviously you're making it more efficient and in a way sustainable for the client in terms of finances and efficiency and time, but is it more arguably, maybe not right now, but is there potential for it to be a more sustainable practice for the environment moving forward?
I think, yes, in the short term, the less intrusive works you do generally is we're using less energy, we don't have generators on site. Or if we can get projects done quicker, we're reducing TM and traffic and all the sort of other stuff that comes out of it, downtime and things. So there is a slight saving there, but I think overall we aim to offer more than you'd get out of a traditional system. And what we would like to do, especially when we start looking at condition and corrosion and the defects within concrete, if we get to a point where we're scanning every bridge, viaduct, dam, whatever it is, more often, and we're doing it quicker. So rather than doing an intrusive inspection every 5-10 years, we're doing a non-intrusive inspection every year. It may not give you quite as much as that intrusive inspection, but if you do it every year, we can start seeing variations, changes, and start predicting defects. And therefore, repairs can be more proactive than reactive, and the life cycle of that infrastructure can last. And the sustainability wise, that removing a bridge and rebuilding a bridge is huge CO2 emissions, it's time, it's money, it's all the other stuff. And if we can just repair it because we've got a better understanding of how it's changing year on year rather than 10 years, which kind of starts being, it's not useless, but it's harder to build up that predictive model. So that's kind of where we see the sustainability coming in. We start doing more. Engineers understand that we can do a whole bridge in a couple of nights. So you can, therefore, if you said you had 3 weeks on a bridge every 4 years, 5 years, but we're doing 1 week on a bridge every year, cost-wise, you're about the same over that 5-year period, but you're getting so much more information. And that's where we think the sustainability is key. It's just the repeatability and efficiency of non-destructive methods.
And it is, I suppose it's the element of prevention rather than cure. So as you said, the more often you're able to analyze the structures, the more data you have to be able to maintain it effectively. So preventing things before they go wrong. Another thought I had there as well, and I know we've touched on this, but if you're looking at a bridge and you have to do, your options are, both are applicable, non-intrusive, or the sort of more traditional methods that we've been speaking about. I would assume that if you went down the more traditional route, the flexibility you have to sort of have that person or that team undertake that traditional investigation, you have less time, because if you're looking at a bridge that is in use constantly, to be able to, I assume you'd have to stop traffic going over it or whatever to be able to undertake what it is you need to do and then come away from it. But I imagine with you guys, because it's non-intrusive, there's less downtime for that structure because you're able to get in and get out a lot quicker and obviously cause a lot less damage.
That's, one of the biggest things. We can do a lot quicker, a lot faster, reduce the traffic management requirements, reduce the health and safety requirements. Bridges, however you look at them, they're above you one way or another. And you're either going up on like a cherry picker from below or an underbridge unit, or you're doing something that is inherently high risk because you're working at high heights. It's mitigated, it's a lot safer than it used to be, but there's still that risk. There's a lot of methods, things like the house bot and drones and systems of getting equipment up there. That means we don't have to put people up there, or we can put people up very limitedly to set up a system that can go and collect loads of data. We still have to close a bridge. There's the risk of things going down in that, but you're there for a lot less time. You're getting a lot more information, and we can reduce the risk to people as well. Even if you ignore all the traffic management, putting someone up to do breakouts and things, you've got dust exposure, you've got noise exposure, you've got hand-arm vibration, you're working at height. We can't remove all that. We still always need intrusive works. But if we do 3 breakouts instead of 100 breakouts, everyone's better off in the long run. So it's a lot of reduction of risk as well.
Yeah. Andy, tell us about iCAM. Now, this is a piece of technology that you guys have exclusive rights to in the UK. And it's coming over from the States, am I right?
From Canada.
Canada.
So it's created by our partners in Spectera. It's essentially, it's a magic box. It has the sensors in it that map the variations in the magnetic field. So every piece of metal in the world has a very weak magnetic field induced by the Earth's magnetic field as it spins and it induces in there. The iCAM is totally passive, so it records this field. So in reinforcement, steel beams, post tensions, pre-tension, pretty much anything that's steel, and you roll it along and it records it. Where the structure of the steel has changed, either from breaks or from corrosion, which is the main thing that happens to steel within structures, that magnetic field fluxes and changes. And the iCAM is sensitive enough to see where those variations are. So we have a concrete structure, steel reinforcement within it. We can run along the steel bars with the iCAM, and we can say that this meter or half meter or 2 centimeter section has 10% section loss, or it has 50% section loss, or whatever is in there. And then the next bar doesn't, and then every bar has X amount of section loss. It's pretty game changing in a lot of aspects, because at the moment you can do half cell and radar to just look at the corrosion risk, how conductive that concrete is, and then the more conductive it is, the more likely that you're going to get corrosion. But then to actually find out how much of the steel is left, you have to break it out. And again, you're breaking out a very small location, which means there could be fine, but over there is not. And the iCAM we can scan alongside those traditional half cells and jet radar methods to say that this steel has 20% section loss. The main advantage with that, or one of the big ones, is the exact figure varies depending on which engineer you talk to, but essentially a bar over X section loss needs to be replaced and a bar under that can be repaired. So if you can say those bars need repairing and those bars don't, that's sustainability. That time, money, risk, all of that is reduced significantly. And the iCAM is fully non-intrusive. We don't need to connect to bars. We don't need to expose anything. It works underwater. It works through concrete. It works through everything that's not ferrous. So if we've got tarmac or paint or plaster, we don't need to strip any of that off. We can just roll over the top of it. So it's a big change. Again, it's fairly new. It's proven, but it's not proven to everybody, and so people still want more trials because they need to see it in their own eyes that it works. Even though we can prove it multiple times over that it can work. So it's still slow to get off the ground, but it really is game changing in the industry. Being able to say how much section loss, what level of like corrosion there is on a steel bar, a steel beam. We've used it for mapping breaks in pre-tension tendons. We're looking at it for post-tension tendons. We've got good results out of that. Steel eye sections and essentially anything that might rust and that rust can cause issues. We can analyze it and see where it is. So it's definitely a really good bit of kit. We're very lucky to have it, and yeah, we're just trying to get more engineers to understand its benefits, really.
So what, in terms there, you gave us the example about sort of measuring corrosion. So what is, to sort of try and paint the picture a bit more for me, what is the alternative? So you use the iCAM and that takes X amount of time and this is the process. What is the alternative to that currently?
To understand how much corrosion is actually on a bar or a thing is generally to break it out. You can determine risk, essentially mapping the conductivity of the concrete. The higher conductivity, the higher the risk. But you can never actually see what that level of corrosion is without exposing it until the iCAM.
Right, okay. So it makes things, again, it's a lot less intrusive. Well, it's not intrusive, and you're getting the answer that you need without all of the aggravation of all of the disruption that an intrusive method causes.
Yeah, exactly that. And yeah, we'll often do a few breakouts to calibrate and things and confirm results and things like that. But if we're doing a 20-meter wall, we can get that done in a few hours and map every single bar within there. Whereas you would have to pick the worst areas based on your half cell map or your radar map, and then hope that, and then basically infer that across whatever, if you find that they're all X, you can infer that across the space. Whereas we can then actually say that it does vary here. And that's really a massive part of what we do, is because we scan everything, we don't need to infer. We don't have to say location 1, 2, and 3 has results X. Therefore, everything's fine. We'll scan everything with iCAM for corrosion or radar for thicknesses and delaminations. And then we can say, yeah, like everything's the same. This area that you cored is actually the best area, but everything else is terrible. So it's trying to, again, give more confidence in the overall sort of information.
And this is obviously a new piece of technology and innovation, and you guys have exclusive rights to it over here. How do you go about doing something like that? I'm just genuinely curious, because this sounds like a game changer potentially for the industry, and you guys have got it in your back pocket. Like, how did you do that?
A lot of it's luck, not gonna lie. So we were talking to some peers in Scandinavia, and they were basically raving about the system and how good it is. And so we went to check it out, talk to the manufacturers. It's their business model is to set up with partners rather than sell the system outright. There's a few reasons for that, but it's still a little bit in development. Like it's as close to perfect as you can get on such an early system. But they don't want to like just sell loads and loads of it, because there's a lot of theory and technology behind it, and to get the most out of it, you need to fully understand what you're doing, the analysis you need to understand and what it is. So you can't, if you just sold it to everyone, there's going to be a bunch of, the understanding won't be there and the results won't be good. So it's kind of that. So they set up with partners, and we're lucky enough to sort of, sell ourselves to show what it is to them and say that we can do great things with you. And over the last year and a half that we've had it, I think we've done loads of jobs. I think the original contract that we had was do 5 jobs in 12 months, and I think we're pushing towards 100 jobs with it
Wow.
in the last 18 months. We're finding it invaluable for a lot of clients. The clients that have got results, they find it invaluable for their works as well. And so we've proved ourselves to them, and they're really happy with what we do. We've advertised it. Anyone who's seen me on LinkedIn has seen that I've bang on about it quite a lot, and then that's got them new clients around the world as well. So it's very much partnership, and yeah, we got there by luck, but we sort of proved what we can do with it. It's proved to us that it's worth having.
Looking to the future and AI. Now, AI has sort of embedded itself in pretty much everyone's life in some form or another. And whether you're a noob that just uses the free version of ChatGPT to sort of improve your emails, your rambling emails, or whether it's, you've integrated into your business or whatever. Do you see a role for AI in what you do? And if so, what do you see that role being?
Yes, there is a role. It's a very cautious role for us at the moment. So ChatGPT, we use it literally as you just said, improving some of the English on our emails. We've tried it for improving on reports and things, but realistically, other than checking typos, it doesn't cover what we need it to do. So it's very limited. In terms of data analysis, pretty much every manufacturer has talked to us about how their AI is brilliant. It does this. It can pick bars. It can do this and it can do that. And it's better than it used to be. There's always been machine learning for extracting bar information from radar data. That's always been there. It's always been pretty bad, and it is better now than it was then. However, it's a very different thing from being able to say, okay, there's a bar there, there's a bar there, there's a bar there. To be able to say, those bars map in with those bars on a scan 5 meters away, and you've got to tie that in with the ultrasonic data and bring it all together. And that's where we specialize. And what we find is the AI is not, for us anywhere, close. And we've tried a lot. Like we're fairly well known in the industry, especially for radar on concrete. And so we get a lot of people talking to us, showing us what their system can do. But we find it very difficult to actually get any value out of it, because it is just, here's a target, there's a target. And I was like, we can see the targets, we know where the targets are. I've not seen any AI that can infer or determine what those targets mean in the larger scale. It's very much, this exists, this exists, this exists. It can be useful. Sometimes you can be like, oh, I kind of missed that, but yeah, it doesn't give you anything extra. Obviously that will change. Have no doubt that pretty much everyone's job will be redundant in the next 50, 100 years. But in the short term, one, I don't think there's anyone developing it to do what we do. And I think it's incredibly complicated to try and say, we like, when I say we scan every part of a building, we're not necessarily scanning that on a really regular grid that an AI system would be able to interpret it. It's, if you ever saw our site notes, there's just kind of scribbles and things here, there, and everywhere. To us and the team know what we're doing, we know how to take that apart. But AI is a long way off from that. So there's benefits if you're just mapping out bars, if you want to tell a bar from a post-tension tendon or things like that. There is really basic stuff that you can do. It's a long way from being able to say, if you fed it 100 ferroscans or 1,000 radargrams, it's a long way to be able to say, this is how the structure's built, this is where it changes, this is where it is. We honestly, like, I'd love to see it being able to do that. I mean, commercially, I don't, because then it entirely defeats the project, like everything that we do. But it would be good to see that it can do more. But it's to me, it's nothing in the next 10, 20 years that's coming in to be able to really pull everything out of the information. Because the other thing is a lot of radar data, especially, is very visual. It is an objective method of detection. It's all ones and zeros, peaks and troughs. But you kind of pull that all together and you're looking at different things in the data. And again, AI is not great on the visual analysis of it, which is kind of what it's there. We do use it for bits and pieces. Some of the corrosion analysis stuff that we do is based on with radar, not with the iCAM, but with radar, there is some AI and calculations that are done, but it's very much helped by people. So it's there, it's coming. I'd love to see more of it for defect analysis. I know there's crack mapping with visuals of videography and images. That's really good. Defects analysis, Rosec Screening Eagle, they've developed a thing. You can take a picture of a piece of concrete or piece of masonry and it will say, this is a masonry, there's cracks here, it's, there's spalling, there's efflorescence, never say that word. And there is things like that help. But again, when you start going deeper into it, it's a long way off.
I suppose as well, there is what you guys do is very serious, and the margins for error are not there. If you get it wrong, then it could potentially be really, really bad. And I suppose what I'm hearing is the ultimate test for it is how confident are you in your AI to produce a report that is going to be accurate enough for you to feel comfortable enough to outsource your risk to it. So, if you're getting this data, you're plugging it into an AI machine, software or whatever, and then it's going to your client, how confident are you in that piece of AI doing its job properly? And then I suppose taking a step back from that, there's also an element of, right, okay, well, we're going to need to assess what this piece of AI has produced. So you're going to have to do the analysis anyway. So there's an argument to say, well, what's the point in I'm sure there are parts of it that it makes more efficient, it speeds it up, but really you have to do the work to double check it. So you might as well just do it anyway. And it's sort of, we have, it's two very, very different industries and we do very different things, but, we use it for efficiency and it definitely has its place in our business within certain areas, but it's very much still the tool. It's not the driver. And where it may, who knows? We don't know what's going to happen, but, indications are that, in the next 50, 100 odd years, that we'll all just be sitting around doing nothing. That's a different conversation, but it may get to that point and it may become the driver. But I think for us, it's very much still a tool. And that's not me saying that I'm against innovation and I'm against trying to find better ways of doing things. But I think there's always that careful balance, particularly in an industry like structural investigations where it is very serious. If it goes wrong, you have to be very careful that you're hitting that balance and that it's on the side of safety and not just convenience.
100%. In my mind, it's more the calculator than anything else. Like a calculator tells you an answer, but if you put the data in wrong, you're going to get the wrong right. It's great at distilling data, but the analytical side of things really struggles. And you're right, like you do need to check it. Like we've chucked data into AI and give you what you actually expect it to do. And when you look at it, it's just made it up for whatever reason. Yes, that would improve. And yeah, if you gave someone, an infinite amount of money and an infinite amount of time and you went to every single report that we've done based on all the analysis and every report that every other company's done, you could start building up that model so that you could do it. I don't see anyone paying for that in the short term.
So the business is safe for now.
I think the business is safe for now. I tell you what though, the one thing I find ChatGPT and AI really useful for is when you get 1,000-page scope and 1,000,000 different things, if you chuck it in there, you can pull out the salient facts and you can be like, okay, this is what I actually need to look at. And then but again, you've still got to read it. You've still got to do it properly, but you can distill things very quickly. But that's more on the commercial side of things. For the actual reporting analysis, we've not found much other than, checking for typos and maybe rewording a paragraph, but you still got to make sure the paragraph still says what you want it to say.
Yeah, exactly. You still need to read it. I mean, I know and we haven't experimented with these, but I've seen them advertised on, social media and various other places where you have these plugins for your emails, where they just can reply to emails on your behalf. And I just think,
Yeah.
I mean, maybe it's just because I don't have enough knowledge about how they work, and maybe they are great and they can just be you and respond to emails. But number one, I'm not sure I get that many emails where I can't respond to them myself, and number two, I'm just not confident that I'd want to substitute me for AI to respond to emails. I've got no idea what it's talking about. But
Well, yeah, it's hard to be like, yeah, it's fine. I mean, there is the emails where you just could be like, yeah, that's fine, whatever. But there's, a lot of it, you do a job, you are paid because you are, a de facto expert in that thing. And a lot of projects, a lot of emails, a lot of things, they don't. It's not just the standard template. Like I can go through my emails now and say like that was got like that kind of, and that's got that, and it depends on your job. But yeah, AI is improving. We are getting more out of it slowly. But yeah, I don't think it's not going to take over the structural investigation industry anytime soon, despite what the manufacturers want us to believe.
Andy, absolute pleasure having you on. Really enjoyed our conversation. Thank you for your time. If our listeners want to find you, where can they find you? Socials?
Website is trace-si.com, and we're on LinkedIn. There's us, me especially, normally talking nonsense about GPR and everything else like that on LinkedIn. But yeah, I don't know if our bio and that will be in the contacts will be in the link below. But yeah, you can get us to our website or numbers on there.
Yeah, all the details will be in the link below. Andy, thank you very much, and I'll speak to you soon.
Been a pleasure. Thanks so much.